All right, in this video we're going to go over using tables to draw graphs and also find a function rule. So we already know how to find a function rule from a table. So remember that's your y equals ax plus b, where a is the constant change that you get between your y values when your x is consecutive. So here you add 2, so there we can just replace y equals 2x, and then our b is always going to be our y term when x is 1, so it's 5. So b is equal to 5 minus our a, which not 3, which is 2. Therefore, our b equals 3. Okay. So now when we graph this, you can do it two ways. One, you can graph the coordinate points. So at 0, it is 3. So you go put a point here. And then when you're at 1, you're at 5. When you're at 2, you're at 7. When you're at 3, you're at 9. Okay, so you've plotted the points, and now all you do is connect them. Okay. So we have our function rule. We have our graph. The other way you could have done it is your b value right here. That is going to tell you where your y-intercept. And your y-intercept is simply where the line is going to cross the y-axis. So if you notice right here, it crosses the y-axis at 3. Okay. And then this right here is referred to as your slope. What is your rise over your run? So you go up 2 for every 1 you go over. And that's what you'll see here. From 0 to 1, you went up 2. You went from 3 to 5. This is also going to be so it's your a, but your a is also equal to your change in x over your change in y over your change in x. I'm going to write it over here. A is equal to change in y over change in x. Which, when you're in consecutive order here for your x is always going to be 1, so then it's just your change in y. This you'd use if you do not have consecutive numbers in your x term. Okay, so next one, we have a plant that grows at 1.38 centimeters for each hour of sunlight it receives. Write and evaluate a function rule to find the growth of the plant when it receives 15 hours of sunlight, then graph the function. So we need to find our function rule, which is y equals ax plus b. A is going to be the constant change. And so we can check, okay, what do we get here when we add, or what do we add to get 2.79? And we'll find that that's 1.38. If we go from 2 hours to 3 hours, you'll find that you added 1.38 again. And then same thing. And this in the story problem lets us know that it grows that much per hour. So that is our a value. So we can write the function y equals 1.38x. And then we would check and see, okay, if we want to find b, it would be 1.38 minus a, which is 1.38. And so that's just going to equal 0. So there is no b value. So this right here is going to be our function. Okay. Once again, to graph it, You could graph that and just note, okay, every time you go up, or you go over 1, you go up 1.3. And on here, you're just going to have to kind of estimate where that value is. Zoom in a little bit. Okay. Now this here, our b is 0. That means it's going to cross the y-axis at 0, which means it's going to pass through the origin right here. Okay, so we can start there with that point. We're going to go over to 1 and up to 1.38. It's going to be roughly there. Okay, then at 2 we had 2.7. So it's roughly there. And then at 3, 4.14. Okay, and I can keep graphing, but at this point I'm just going to draw my line. Okay, and at 4, see, this should land real close to 5.5, and it does. Okay, so there we've graphed our points. We're using these as our coordinate points. So this would be 3 and 4.14, and so on. Okay, so there we've found our function rule. We've graphed it. Now the last thing it wanted us to do is, what is the height going to be at 15 hours? So for that, on a graph, you could use the graph. I'm just going to plug in 15 for my x in my equation. So y equals 1.38 times 15. And when you plug that in, you're going to get your solution, your height. And so that's going to equal 1.38 times 15 is going to equal 20.7. So this plant will be 20.7 centimeters high after 15 hours. Okay, so there we were given tables to fill out. Now we're going to look at filling out a table and answering questions based on the graph we have. So the graph here, it shows that, or it represents the distance Tom travels over time. So notice we start at the origin, so that means our b value is going to be 0. Okay, and notice that in 1 hour we go 20, in 2 hours we go 40, in 3 hours we go 60, in 4 hours we go 80. So we're seeing a pattern that we're increasing 20 each time. Well, that increase is going to be our a value. So 20x. Okay, and once again, b is 0 because it passes through the origin. And if you think about it, he's not going to go any distance if he spends no time driving or traveling. So, okay, so this first one though, it says what is Tom's speed? So that speed is what our a value is. So he's going 20 miles per hour. Okay. What you'll also notice is that this is your unit rate. So if you go back to proportions and finding unit rate, this is how far he goes in 1 hour. Okay, so we're just going to keep multiplying that by the number of hours he travels. This is also the slope. So we'll get into that later, but that's the slope, the rise over the run. Okay, and I wrote that function rule in the wrong spot. It was down here. Okay, this B question, is this a function? It is a function. Remember, a function has only one output for each input as it goes in. So there is no other point when x equals 1 other than 120. Now, if there was a point here on the graph, well, when x equals 1, it's also saying it's 50. Now there's 2 points. So this would no longer be a graph. This would no longer be a function. But in this case, it is a straight line. There are no other values for y when x is 1. Okay. Last part just says to complete the table of the data. So we have our points here, so we're just plugging in our y value or our input. And we could go, if I said I want to know what it's going to be after 10 hours, we'll fill that into. But here, so at 1 it was 20, 2 it's going to be 40, 3 it's at 60, 4 it's at 80, 5 it's at 100. So then at 10 we're just going to multiply 10 by 20 and get 200. Okay, so we can use these points to fill out the table. And this table is just a representation of the coordinates of points on the graph. Okay, you've got your x value and your y value. Okay, last thing, so in this instant here, we're going to graph the functions. So there are two ways you can do this. So you can think of, okay, what is my y-intercept, and start with that point, and then you're going to go up 3 over 1 for the slope. The other option is to just fill out your table and graph your points. So we start when when x equals 1, you get 3 times 1 minus 2. So that's going to give us 1. When x is 2, you get 3 times 2 minus 2. So that's going to give us 6 minus 2, which is 4. When x is 3, we get 3 times 3 minus 2. That's going to be 9 minus 2, which is 7. And so on. So you can keep plotting these points. So at 1 it was positive 1. At 2 it was 4. And at 3 it was 7. Okay. So if I connect these points, I'm going to have my graph. And one last point I'm going to mention is this right here, my y-intercept, which is this -2. So that's another point that you can graph. So note when looking at graphs of functions, whatever your b value is, it's going to go through that value. That's going to be your y-intercept. So in this case, at 0, -2, it's going to pass through that point. Okay, next one. So once again, we can create a table. In this one, I'm just going to do x and y. So when x is 0, 1, 2, and 3. Okay, so this will be enough to give me a good idea of my graph. And this is a -2, where this is a +3. Note that with a +3, it's going to be increasing. So now with a -2, what we're going to notice is this is going to be going down. So if your a is positive, it's increasing. If your a is negative, it's going to be decreasing. All right, so when x is 0, our outcome is just going to be 0. Okay, which means it's going to pass through the origin right here. Okay, when x is 1, we get -2. When x is 2, we get -4. And when x is 3, we get -6. And all I'm doing is just plugging in my x value here with what my x value is in the table, and my output is going to be my y value. So now to graph this, so at 1 it's -2, at 2 it's -4. I'm going to scooch up just a little bit here, and at 3 it's -6. Okay, so once again, you can draw a line connecting all these points. And there we have our graph. So that's just how we use tables to draw graphs. Also, how we use function rules to draw graphs, and how we can come up with a function rule from a graph, or how to draw a table from, or fill out a table from a graph.